I am the Launch Director for the Launch Services Program. And so, sounds like a pretty cool job.
It does.
It is.
EGS Program Chief Engineer. Verify no constraints to launch.
EGS Chief Engineer team has no constraints.
I copy that. You are clear to launch.
5, 4, 3, 2, 1, and liftoff.
Power clear. Now passing through max Q, maximum dynamic pressure.
Welcome to space.
Welcome to the Rocket Ranch. I'm Amanda Griffin. Earlier this month, our host, Joshua Santora, sat down with two Launch Services Program powerhouses, Mick Woltman and Tim Dunn. Between the two of them, I'm pretty sure they could power a rocket with their charisma alone, and they have nearly 4 decades of launch services experience between them to boot. Since the recording of this interview, the ISAT-2 mission successfully launched on the last Delta II, and the Launch Services Program is now 5 for 5 on successful missions this year, with the 6th still to come. Needless to say, these guys are pretty busy, so let's get on with the Rocket Roundup.
Today, I am in the booth and joined by Tim Dunn and Mick Woltman of NASA's Launch Services Program. Good day, gentlemen. I want to let you guys introduce yourselves briefly. Tell us a little bit about yourselves and kind of what your role is for NASA.
Well, Joshua, thanks for having us today. My name's Tim Dunn, and I am the Launch Director for the Launch Services Program. And so, sounds like a pretty cool job.
It does.
It is.
One of the coolest.
Gosh. Mick, it's been almost 18 years.
Almost 18 for both of us, Tim.
Yeah.
We started at Launch Services Program about the same time, same year. I think it was in 2000, 99, 2000. We both joined NASA's Launch Services Program. Ironically, we both joined in the electrical avionics branch. And a couple years in that branch, we both moved over and became vehicle systems engineers. And just recently, probably within the last 5 years, we kind of split our ways. Tim went to the launch manager's office, and I went to the fleet systems management area there. For myself, I'm Mick Woltman. I'm the chief of fleet systems and integration in the program. My branch is in charge of all the system engineering for the launch vehicles. Another cool job, not quite as cool as the launch manager, but
it's pretty cool.
But it's pretty cool because we get to do all the engineering and assessments of all the launch vehicles that Launch Services Program works with.
So you guys are both with the Launch Services Program, or LSP, and you guys, I would describe you guys as kind of the unsung heroes of NASA and spaceflight for 2 decades now. I'm expecting that people are surprised to hear you've been around for 20 years, because my expectation is people would say, well, I've heard of the shuttle program, I've heard of maybe SLS, I've heard of SpaceX and Virgin Galactic and Boeing and all these other companies that are out there. LSP? What? Who are you and what do you do? So give me an overview of what do you guys do as a program?
So I would say as a program that's named Launch Services Program, we have only been around since 1998. So this is our 20th year. However, the heritage of LSP really dates back into the late 50s and 60s.
Absolutely.
So our predecessor organization that was located here at Kennedy Space Center was called NASA Expendable Launch Vehicles.
Okay.
So
ELV.
Not a real jazzy name. We needed to tighten that up.
Sure.
And then we had a lot of expertise in expendable launch vehicles that were located at Goddard Space Flight Center, and at the time Lewis,
right,
Flight
which is
Center.
now Glenn.
Okay.
Right. So in 1998, NASA as an agency co-located all of that expertise in expendable launch vehicles here at Kennedy Space Center and gave us the new branded name of Launch Services Program. So what we do,
Right.
In just very short amount of time, if I could summarize it, it would be we match up the needs of spacecraft with the right size of the rocket. So small spacecraft doing low Earth orbit activity, small rocket.
We don't just have one rocket. We find what's best needed for the spacecraft customer to get them where they need. And if that requires an Atlas V, we do that. If that requires a Delta II, we do that. Pegasus or a Falcon 9 or a Falcon 9 Heavy, Delta IV Heavy. We have those all available to us to choose from as Launch Services Program. We have expertise in all those vehicles, working with our contractors on those. We assess all that and determine what's needed. So you could kind of say we broker, right? We're NASA's bridge to space, if
Sure.
you will.
Yeah, love it.
With our spacecraft customer, providing them a ride. Now, what's unique about that, and we can talk a little bit about this, is compared to all the other programs people have heard about, shuttle, SLS, all these, Launch Services Program, we work with private contractors who build rockets. So the United Launch Alliances, the Northrop Grumman Innovation Systems,
Space exploration technologies.
Yes. And they actually own and build and have done a lot of the design of these rockets. Although some of the technology and stuff's been around for many, many years, they build these rockets. We then work with them to make sure we have the right rocket for the right mission to make mission success. And a lot of us, as you heard from Tim and I, Tim started back with McDonnell Douglas on the Delta, myself with GD Lockheed on Atlas. We have a lot of background in those type of things. And we came to NASA to help do that. So that's one of the big differences that probably why people didn't know about Launch Services Program early on when shuttle was flying and stuff is we are kind of brokering that with our private contractors to get NASA's missions on orbit.
And one good thing that we like to tout for the taxpayers out there
absolutely
is that because we have this,
or those that will be paying taxes,
we have this stable of rockets in our catalog, and so we're able to compete our needs against these multiple commercial providers, and thus get the best product and price for the American taxpayer.
Yeah, and what's unique about that is being rocket engineers that we are. I'm probably dating myself here, but all of us have a poster of all of our favorite rockets, that are in our offices and things like that. But we kind of have that centerfold picture, if you will, taped up in our office of what our favorite ones are. It's true. It's there.
That makes you guys sound really nerdy and geeky. Like, you know that, right? Like, I just want to
like we are.
We are. Yeah, we have no qualms about telling you that we are.
That's good. That's good. Own it, man.
Our program manager, Amanda Mickiewicz, we just recently did some work, and she was telling somebody that if you really want to see my folks and how passionate how they are about their jobs, just go ask them what their hobbies are when they leave work. They work on rockets all day long, and they love it, but then they leave work and go ask them what they do. A lot of us go play golf. A lot of us do model rockets. A lot of us do engineering things. We work with outreach. It's just what we like to do. Yes, we know we're nerdy, and we love rockets.
So did you guys grow up as NASA or space kids, or is that something that really, it didn't happen until you got close to that launch?
So I guess I would say what Tim and I have learned working with each other over the years is, and you can jump in here, is we actually had very similar ideals and dreams growing up. One of my favorite shows growing up was Star Trek, the original.
Awesome.
The original.
Unfortunately, you will hear Tim wanted to be a certain character. I believe his name was Captain Kirk.
Captain Kirk. Who didn't want to be Captain Kirk?
That's a good question.
Well, that was me. I wanted to be Scotty. So I think it worked out great because I wanted to do engineering. Tim became the launch manager. He runs the launch team as captain. Right? So, but yeah, we both loved Star Trek.
Yep.
Model rockets,
yeah.
Which, by the way, we still do today with students and outreach and stuff. When we get asked, you can't keep us away from doing either air rockets or model rockets. Tim and I love to go out and do those still, even as we are still youngsters at heart. So
cool. Very cool.
So yeah, we had a lot of the same things growing up that led us to this job.
Really neat job. So a little bit about myself. I was born and raised in Alabama, small town. Went to school at the University of Alabama, got an engineering degree. The Air Force offered to pay for my schooling, so I owed them a few years. I went off and I flew satellites with the United States Air Force for a number of years. Air Force was really good to me after that really cool first assignment, flying satellites, GPS satellites, by the way. I got to go back to graduate school, got a graduate degree in orbital mechanics and the physics of space science, and I parlayed that into an assignment here in Florida at the Kennedy Space Center and Cape Canaveral Air Force Station. I was on an Air Force launch crew, and then once you get launch in your blood, Mick, what happens?
Absolutely, it stays in your blood, Tim.
So I couldn't leave Brevard County. I couldn't leave Kennedy Space Center and Cape Canaveral, and here I am. I was very fortunate to get a follow-on job offer from McDonnell Douglas. Did a little bit of work with the Delta II rocket.
I grew up actually here in Florida and kind of bounced around a little bit, but ended up in Tennessee. with my dad traveling the southeast area, so we did most of my stuff there in Tennessee. Went to Tennessee Technological University for my electrical engineering degree. Started my master's in engineering management and electrical at the University of Tennessee. Go Vols. Sorry about the Alabama there. And then came to Florida and finished that up here at UCF. So a little bit of a mixture in college life, but enjoyed my engineering time there. A lot like Tim, who went in the Air Force, I came right out of college and went to work for the Department of Energy in Tennessee, designing guidance chips for submarine missiles. And then I got picked up by General Dynamics, Martin Marietta, Lockheed Martin, that whole merger after Shuttle Challenger, and started working at Complex 36 here at Cape Canaveral Air Force Station. And like Tim said, once you get that first launch in your blood, you want to do that. And so I did. And fortunate enough, we're still launching rockets, still loving it, working with the people we love, and doing what we dream of every day.
So very similar career paths, as you can see.
Yeah.
Although Mick does wear that color of orange to the office just a little bit, and I wear that much more palatable crimson
red. Yeah. We have a fun time with our SEC football. When Tim and I started working together in LSP in 2000, we kind of found that bond that we had, even though approached this from different tracks, if you will, or different ways, we came to the same job of what we love to do and still love to do today.
Yes, absolutely.
Yeah, that's awesome. So, no humans for Launch Services Program as part of a spacecraft, correct?
Correct.
But pretty much or I guess barring a few that flew on shuttle, every NASA science mission since the inception of the program in 98 is all LSP. Is that accurate?
I would say about 98%.
Okay.
There are some occasional missions that will fly as rideshare on maybe an Air Force launch or a National Reconnaissance launch. Some have flown as rideshare on Soyuz missions and are then attached to the International Space Station. But certainly anything that's large and is doing big science, either here in Earth orbit or going interplanetary, you can bet there was an LSP stamp on it if it's launched in the last 20 years.
Yes.
Awesome. Yeah. So tell me about so obviously you have a finite number of rockets available as your ride. There's not an exponential number out there. So what's the landscape looked like as far as the options that you've had historically, and are we seeing a change now? It feels like there's a growing market in the commercial world.
Absolutely growing market, and again, LSP is I would say out front in looking at the market, and some of our venture class are next. Some of our new competitors or emerging rockets that are coming up that you hear out there. LSP is looking at those and working with them. We're always trying to strategically think ahead of what's the next best thing for NASA, our science missions. So people have probably seen Blue Origin, or
if they haven't, they will soon.
Yeah, or they will soon. Yeah, and or Rocket Labs, right, and Launcher One,
right,
Firefly, and we're working with these companies to understand their rockets, to look at how they're doing business, and eventually maybe get them in as part of our catalog. But you got to start somewhere, and we have a lot of stuff coming down the pike. A lot like people know SpaceX, right?
Sure.
When SpaceX first came on the scene, which I can't believe has now been almost 10, 11 years, 10
I
years,
think
something like
16 years
now.
Oh,
it's been a long time.
2002, I think.
But we think of them as just starting out, right? But when they first started out, we got involved with them and following their early launches and looking at them. And then eventually SpaceX became one of the rockets we had available for our customers. So, I think we're always out there looking at the market and creating new opportunities.
Yeah, I think historically, kind of as Mick and I were coming up through the 80s and early 90s, there was generally like smaller rockets, some medium rockets, and then the bigger rockets. So Mick and I kind of grew up as we've talked about. Pegasus has been around since, I guess, was that late 80s, early 90s. And that's a very small market. And then Delta II was in that kind of medium class, Atlas, and then the big rockets were Titan IV, and then Space Shuttle.
Yes.
So now,
and so we got to see the evolution of Atlas V and Delta IV. That design was during our time.
Right.
to meet some bigger payloads when Titan went away. So those
yeah.
were kind of our stable while we were growing up.
Yeah, so we were able to kind of see Titan be retired, but Lockheed Martin grow the Atlas II at the time into the Atlas III, and then now the Atlas V, which has become just an absolute gold standard in launching now for large spacecraft.
And we got to see, I just thought about this, is we got to see companies who, he worked for McDonnell Douglas, I worked for Lockheed Martin, and you got to see these companies get together also and form, in this case, United Launch Alliance. So you had two rocket companies who got together and created one and kind of merged technologies and rockets together to create another family, right? And they're even moving forward with the Vulcan rocket that's coming out, their new design. And Northrop Grumman started with their small Pegasus. They've built an Antares vehicle that we have and look at, and they're now looking at another vehicle called Omega.
Yeah, larger rocket there. So
the market is continuing to grow.
And as Mick said, we keep building relationships with all of these emerging launch service and rocket providers, and look forward to that first launch for Blue Origin here in a few years.
Actually, going back a little history-wise, I'm excited about that one because they're going to be launching off of Complex 36.
Okay, which you mentioned earlier.
Which is where I started my career, launching Atlas rockets, which got decommissioned, and Blue Origin moved in and started rebuilding. And to that point also, back just recently, July 12th of 2018, Space Launch Complex 17 was taken down, where Delta IIs launched out of for many, many years, and now that's being repurposed by another launch company.
Right, correct.
To do. So it's exciting for Tim and I to see some of these changes and how the market evolves from there.
Big year, anniversary year for you all. Congratulations to the program and to you guys.
Thank you.
And obviously a huge year. I don't know that there's ever been a year with this many launches this close together. Talk a little bit about kind of this year for you guys as a program.
Well, I'm gonna jump in real quick because I'll let Tim talk about the year, but I will say it's an exciting year for us. It's our 20th anniversary. We're so happy to be here. And for all the years we've been with the program, this is one of the busiest years we have, and I'll let you talk about that.
So for just a moment, let me kind of summarize 2018, and then I want to go on. Joshua, I'm not sure how much time you have because I can talk for a long time.
We could talk all rockets if you want, Josh.
Yeah. But we got a few other things I want to get to. Let's not go too long.
What's exciting about 2018 is that we're launching on 6 different rocket configurations.
Yeah.
So we're launching on a couple of Atlas V configurations. We mentioned Falcon 9 launch tests. We're launching on Pegasus. We're launching on the Delta IV Heavy, and finally, next up for us is the Delta II. Yeah, so Mick and I are both individually blessed to be in the positions that we are, and we absolutely love our jobs. But I would say our program, Launch Services Program here at Kennedy Space Center, we're blessed to have the job that the government has entrusted to us.
Yeah, we're a family. I refer to it sometimes as a dysfunctional family, but we're still a family.
A very successful dysfunctional family.
Absolutely, we are. We love working with everybody we have. So we are. Tim's right. We're blessed to be where we're at.
So through our 20-year history, we've had very busy years, and we may have had a year or two as busy as this year, but 2018 is particularly busy for us. 6 launches this year. We're very fortunate. Here we are, and we've had 4 of our 6 launches successfully occurred. A tremendous amount of work have gone into those 4 launches.
And a couple historic ones, too.
Very historic.
I want to caveat for a second that we've only attempted 4 so far. So we have 4 successful out of 4 attempts.
Well,
2 to go.
We're 4 out of 4 with 2 more to go.
Yeah, so you're right. I wouldn't say attempted. We actually launched 4.
I just want to make sure people don't know that we only launched 4 of the 6.
No.
We've only tried to launch the 4
and
so far.
And hopefully we're going to talk about the other 2. But what I was saying, historic year for us too. Tim and I like to talk about as one in particular. Starting off the year was our GOES-R satellite, which was a follow. GOES-S. You're right.
Yeah.
Which was a follow-on to GOES-R that we'd done the year before, which is the new weather satellite, first of its kind, bringing all kinds of data back for weather and scientists. And then InSight, which was a very historic launch for us. It was our first Mars mission off of the West Coast out of Vandenberg Air Force Base. And then recently,
We had the test launch
Well, that's
in
true.
April.
That's true.
We launched for the second time as a program off of a Falcon 9
Awesome.
test, which is a really cool satellite that's out there in space right now looking for other Earth-like planets.
The sequel to Kepler.
Absolutely.
Awesome
Yes.
mission.
Yes.
So do some homework. There's some cool science out there happening right now.
And then
Right.
the one we just launched, which was a lot of work for the team, and
Tremendous amount of work.
So proud of the program, how much effort was put in by everybody.
Why was that so hard, man? What rocket was that?
That was a Delta IV Heavy.
Heavy. Emphasis on
The
heavy.
first one for LSP, correct?
First one for LSP, Launch Services Program, Heavy mission, and we launched a satellite Parker Solar Probe, named after Dr. Eugene Parker, who first time NASA's ever done that, is named a satellite after somebody who's still living. He was here for the launch and so excited to see that go. But that was a historic mission too, because it's on its way to the sun.
Yep. Mission that's going to, quote, touch the
Touch the sun.
So
Yeah.
we're
Yeah.
very excited about that. But let's talk for a moment about Delta IV Heavy, our first launch as a program on that rocket.
Yeah, it was.
Huge rocket. It's hard to describe how big this rocket is, and the incredible team that United Launch Alliance has that has put together, designed, and prepares that rocket for launch.
Yeah, it is. I mean, you think about it compared to some of the other rockets in our stable, right? Delta IV Heavy has 3 common booster cores.
Yep.
So there's the extra work that has to go in there and integrating 3 cores together to lift off from Earth at
Right.
the exact same time.
Yeah, 3 cores. So think of 3 rockets sitting side by side, tied together
Yep.
on the launch pad as the first stage.
Each one with its own engine, an RS-68A engine that provides a lot of power to get out of Earth's atmosphere. But yeah, like Tim said, that trying to integrate all that together, which is just the first stage, right? And when we call a first stage, that's just the part of the rocket that we use to get out of Earth's atmosphere. It's just the first basic part. In our case, the
Lots of
bottom.
power.
Lots of power.
Lots of power.
Provide us that velocity and speed to leave Earth's orbit. And then, of course, we have a second stage, which is sitting on top of that first stage, which we refer to as a booster. But the second stage is a small motor, and not really small for Delta IV. I shouldn't say that, right? It's actually a pretty large Delta cryogenic second stage, which uses high-performance fuels and to get the spacecraft on its way once it's into its intermediate orbit. And then a mission-unique thing, a thing we did specifically for Delta IV Heavy, was we added a third stage solid rocket motor.
We don't fly many third stages, but this solid rocket motor that we've had great heritage with, Northrop Grumman designed and developed this third stage, and that was the final push that Parker Solar Probe needed to get it on that intersecting orbit with the sun.
So incredible mission. You were saying do your homework on some of the others. I'm sure a lot of people out there that are listening to us today have seen that in the news, and I would say go check that out because it's a real exciting mission. 60 years in the making to do something like this, to get this close to the sun.
Yeah, we covered a good bit of that content with Nikki Fox, Dr. Nikki Fox, in one of our previous episodes.
She is so
be sure to
excited.
catch that.
Nikki
She was great.
is terrific.
And
Absolutely.
I want to make sure we touch on these last 2. So
Yes.
Still to come, we have the final Delta II mission, the little brother, I'll call it, of the Delta IV, and then the Icon on board a Pegasus. So give us a real quick kind of a snapshot of what those 2 launches look like.
I'm going to let Tim, I'm going to do Pegasus first because, as you said, the Delta II is our final Delta II launch. And both of us have a lot of history with the Delta II, but Tim has, you heard from his background when he came in the Air Force early on. Tim has a tremendous amount of that, and this will be an emotional rocket launch for him. And so I'll let him talk the Delta II. But to correct you just a moment, when you said little brother of Delta IV, I and Tim may agree or disagree, I don't know, but I would say actually I think Delta IV was the evolved little brother of he might be a little bigger and a little more stout, but Delta IV was the evolved little brother from Delta II.
If you draw the family tree in a certain way, you might call Delta IV the grandchild of Delta II.
Yeah, exactly. But on that note, I'll talk Pegasus really quick. Icon mission, which is our ionosphere mission that's coming up. It will be our last mission of the year. Is launching on a Pegasus XL launch vehicle, which is a unique airdrop vehicle that we actually mount to the bottom of a modified L-1011 aircraft, an airplane.
Which is more or less a commercial.
Commercial
plane.
It was a commercial plane. For us, Josh, us older guys, we remember the L-1011. For you,
I don't know what you're talking about.
Right,
I don't know what you're talking about.
For you, I would compare that to the new Boeing 767 or 7.
I know what that means.
Right.
Yes.
But the L-1011 was a mighty plane, wide body plane that was used for transporting folks all over the world back in its day. But Northrop Grumman Innovation Systems took an L-1011 and modified it to be able to put this Pegasus XL rocket under the belly of the plane. The plane actually is called Stargazer. And so Stargazer takes Pegasus, and we lift off. We go to 39,000 feet. And once we're at 39,000 feet and Tim, as a launch manager, and the launch team give the go for launch, we drop the Pegasus. 5 seconds later, it auto ignites itself and heads off into space to deliver Icon on its way for its science. So we're really excited about that mission. We always like working with Pegasus. It's a as Tim likes to say, it's my smaller brother. So
real quick, I want to ask you 2 quick questions about that mission and the Pegasus in general.
Yeah.
How big is the Pegasus compared to that commercial plane, just to give people a feeling for how big it is? And why launch from an airplane? Like, that seems like a really weird thing. Why not just do it like every other rocket and go from the ground?
So airdrop has some advantages for smaller payloads, and that's what Pegasus is, right? 1,000 kilograms or less type of payload, and you can put a smaller payload on there, science payload, and use the L-1011, instead of having it launched from the ground, you can get to 39,000 feet and give it a little bit of early start, if you will, right, to get out of Earth's atmosphere, right? So you're at 39,000 feet, so you don't need quite as much energy in your fuels and your boost to get out of Earth's atmosphere and go. So that's one of the advantages to the smaller rocket on the L-1011, the airdrop vehicle, right? Tim will talk a little bit about Delta II and some of the solids and stuff we need to put on there. But that's one of the advantages.
Another advantage is what plagues us the most in the summertime
Exactly.
in Florida? Weather.
Yeah.
Weather. Well, guess what happens when you fly to 39,000 feet? Mick?
Not so much weather?
Not so much weather.
Cool.
The biggest thing you have to deal with at 39,000 feet is the temperature. And so we designed the rocket and all the components to meet that cold temperature while you're cruising at 39,000 feet. So Tim's absolutely right. You pretty much take the weather out of the equation for launch day, right?
And
Go
how
ahead.
big is the Pegasus
So
compared to the
the
airline
Pegasus is actually only 50 inches in diameter. Okay,
Just over 4 feet.
Just over 4 feet,
Okay.
50 inches in diameter underneath the L-1011, right? And the length of the Pegasus is about
What would that be, about 42 feet or
42 to
so?
50 feet. I always try to, in my mind, I always remember 50-50, but it's
Yep.
actually a little bit less than 50 feet long
Yep.
with a Delta wing on it. So it's a pretty small rocket. I mean, I don't want to take away from it. It's a
Sure.
mighty rocket and what
Absolutely.
it's designed to do for, but compared to a Delta II or an Atlas V or a Delta IV Heavy or a Falcon 9, it's small in diameter and small in length, right? So you think of that less than 50 feet long and 50 inches in diameter, and the wingspan of an L-1011 is about 2 to 2.5 times that,
Okay.
right? So you're looking 150 feet, roughly 100.
Sure.
So they give you an idea of the wingspan and how that sits underneath the belly of the L-1011.
Cool.
But very important, Northrop Grumman has been doing this for years. This will be our 44th Pegasus
Sounds right.
that Northrop Grumman
Yep.
has launched. I believe that's correct, and we're really excited and getting that off the ground. But our next one up,
Yeah.
our next
Delta
one,
II.
which is always
The
the most
grandfather.
The most important.
which is always the most important one. The
Whichever
most-
one is next.
Which whenever's next is the most important one, and that I'm gonna turn that over to Tim because it is a very special rocket and we have a lot of heritage with it.
So next up for our launch services program, we're going to launch the final Delta II, and the payload there is ISAT-2. And it will be the final launch. We are in our 30th year of flight with the Delta II launch vehicle. It's had its debut flight on Valentine's Day, February 14th, 1989.
Awesome.
And so it's has become known as the industry workhorse Delta II is not a huge rocket. It's in itself.
It's not tiny.
But it's not tiny.
Yeah, it's not tiny.
It's only 8 feet in diameter.
Yeah, 8 feet in diameter, about 130 feet tall. Yep.
Yeah, we refer to it as a medium class rocket, but
Yep.
it's a mighty workworkhorse.
And
it has been for NASA.
What's
and other
special about
agencies.
Delta II is this is going to be the 155th flight and the final one for Delta II. And it kind of created its own market in that medium class of launch vehicles because it became known as that workhorse, that dependable, reliable, relatively low-cost launcher. And so our spacecraft, a lot on the science side, decided back in the early 90s, let's just design our spacecraft to fit on Delta II. So
wow.
it kind of grew its own class and size of spacecraft market.
Which I want to get into that some more in a little bit, but that's very backwards of how most everything else works for you guys, correct?
Right.
Correct.
Okay,
Right.
yeah, so we'll come back to that. That's really interesting.
Yeah, to just kind of elaborate on that, one of the things that was unique about Delta II back in the 80s, when it came around, it was a big block buy, or what that means is they bought a lot of rockets. The Air Force did, and Tim was part of that in the with their GPS satellites way back then, and that kind of got things going. But like Tim said, they started designing the satellites to fit on the rocket. So a little backwards than what we normally do, but it worked.
Yeah, NASA has benefited greatly from the Delta heritage of launch vehicles dating back to 1960 and Delta I. But focusing on Delta II, the Air Force, we have to, we'll take a moment here and pay homage to our partners, the United States Air Force. If not for them, Delta, the fleet, could have easily been retired in about 1986.
Yeah, and actually production on Delta vehicles was halted in 1981 because if you recall what happened in that year or that time frame was shuttles started flying.
Yeah.
And the government said we are going to deploy all commercial satellites from shuttle.
And the Air Force, meanwhile, had Atlas. The Atlas I and the Atlas II was coming online. They also had Titan. So they really didn't need the Delta anymore. But
the space shuttle was supposed to be flying monthly almost, just delivering payload after payload.
Multiple times.
It was supposed to. It was referred to as the semi-truck of space, right? It was supposed to deliver a lot of things on orbit and all that. And then in 1986, Ronald Reagan declared that we wouldn't launch commercial satellites on shuttle anymore.
Sure.
So Delta.
So the United States Air Force needed to get these newly developed global positioning satellites on orbit. Previously, they were going to fly on the shuttle. Now they're being manifested on expendable launch vehicles. Right. The Air Force said, hey, let's go redesign the last version of the Delta I. Let's call it Delta II. Let's upgrade it, make it a little beefier, launch bigger payloads.
Right.
They provided that infrastructure here at Cape Canaveral Air Force Station at Complex 17. And so it was kind of on that foundation that the NASA science community was able to leverage and say, wow, let's go back to Delta with these slightly smaller spacecraft for science purposes.
So it is the final Delta II for us as LSP for the production of Delta II out of Space Launch Complex 2 out at Vandenberg. But, and why I said earlier it's a little emotional for Tim, it's not only the end of an era for Delta II, but, this is the third time Tim's had to say goodbye to Delta II.
Talk about that a little bit because
so
I know I haven't had a lot of experience because I'm not as invested in the history of NASA, but I know that there were a few years ago we Delta IIs were gone, and all of a sudden Delta IIs were back.
So NASA in September of 2011 we launched the Grail mission off of 17B, which was supposed to be the last Delta II.
Right.
And
from the East Coast.
From the East Coast.
And then we had a month later, we went out west to Vandenberg to launch the NPP mission, which was the absolute final Delta II.
The last one ever, right?
We mean it.
And so in 2009 was the Navstar mission, which was an Air Force mission on 17A, and that was the last mission off 17A. So 17A and B were decommissioned on the East Coast.
Okay.
And then NPP last launch off of Space Launch Complex 2. So Tim had to say goodbye during all that time. And then a few years later...
That's right. Then ULA, United Launch Alliance, who builds the Delta line and the Atlas line, they said, but wait, we have a few extra parts.
More.
There's more.
There's more. And NASA had 4 science missions that had just come out and been approved.
Right.
The OCO 2 mission, the SMAP mission, which is a soil moisture mission, the JPSS-1 mission,
weather
satellite that we just launched recently, and of course ISAT-2. And they all approach Launch Services Program, and they're all within the Delta II range of weight requirements. And so NASA turned ULA on to manufacture the last 4 Delta IIs, and that's where we are today. So I can honestly say that there are no more parts left.
There's always a few spare parts, Mick.
There's something out there.
What are you doing this weekend? I think we might
You said this was a hobby, right?
Yeah.
We extra time. You never know what we could tinker with.
There, United Launch Alliance does have some parts out there for a fifth vehicle. But I believe it will find its way to some other areas. So I can probably, with 99.9% certainty, say ISAT-2 is the final launch of the Delta II.
Awesome. Hey, guys, we need to kind of wrap it up. I wanted to ask you to give me a little bit of feedback, kind of your opinion. If you could leave people with one piece of knowledge or understanding about what LSP does, about how important it is, what would you say?
Wow, Joshua, I would say that Launch Services Program is the government organization that provides the mission assurance capability, the analytical capability that gives us the best chance that we're going to have 100% mission success for whatever science or robotic spacecraft we're about to launch. We have some of the finest engineers and analysts worldwide. It's just amazing when Mick and I get to walk the halls of LSP on a daily basis, the people that we interact with and that have been assembled, and everyone is just so enthusiastic about doing the job, doing it right.
Absolutely.
And just absolutely loves rockets, loves the spacecraft, loves the fact that they're part of something special for humankind.
Yeah, I totally agree, Tim. I think Launch Services Program, we have some folks that are just world-renowned people that are called upon by other agencies, called on by other contractors sometimes to provide input. We have a great team, and when I say team, it's really, I referred to it earlier, it's a family. I mean, the whole LSP program from the top down is a family. And the other thing I would say is everybody we work with that I know is so passionate about their jobs and what we do and making history, because that's what we feel like we do, is every day working for NASA, working on some of NASA's most important scientific and robotic missions. We make history doing that, right? It's just exciting for us to get to do that. Our number one job is to make sure our spacecraft customers meet their requirements and get on orbit successfully, exactly where they need to be on the specific orbit they need to get their science done. And we do not take that lightly in Launch Services Program. That is part of our mission, is to open up the universe, for our people and spacecraft to get things done. And yeah, we talk rockets all day long, but we're in it to make sure our spacecraft customer succeeds.
Awesome. Well, Tim, Mick, thanks for being in the booth with me today.
Thanks, Josh. It was fun.
It was a blast.
And good luck with Delta II, good luck with ICON, and good luck with the future of science and space.
After recording this podcast, our host Joshua Santora had the honor of being the launch commentator for the last Delta II flyout. This historic launch on September 15th was a great success and will hold a special place in the hearts of Tim Dunn and Mick Woltman.
15,
Stop and go.
14,
Green board.
13,
There's
12,
that green board call.
11,
that is great.
10,
9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff of the final Delta II, launching nearly 3 decades of science research and exploration missions, lifting ISAT-2 on a quest to explore the polar ice sheets of our constantly changing home planet.
Godspeed, Delta II, and thank you for your almost 30 years of unparalleled excellence.
You all made this look easy. This is rocket science. It is not easy, but the team looks like they just did a great job pulling together today. But on a personal level, Tim, we know that you love the Delta II. Obviously, you are committed to every mission and do a phenomenal job. So what's this one for you personally?
besides being excited, what does it mean to you personally?
Well, obviously, I'm a little bit sad. I'm thrilled with mission success and that we were able to close the chapter on Delta II with a huge success of an incredibly important science payload. ISAT-2 is going to do cutting-edge scientific data gathering. The precision measurements it's going to make from space are just going to be incredible. So to be able to say that we launched this very important science mission on the final flight of the industry workhorse is just a huge accomplishment for the entire team. And so I have a lot of personal feelings about Delta II, but I'm really just a very small part of the entire team. And I'm just proud, honored, humbled to be part of this team that gets to close the chapter on this incredible rocket.
I'm Joshua Santora, and that's our show. Thanks for stopping by the Rocket Ranch. And special thanks to our guests, our aspiring Trekkies, Mick Woltman and Tim Dunn. To learn more about all things rockets, go to nasa.gov/launchservices. There are also several NASA podcasts you can check out to learn more about what's happening at all of our centers at nasa.gov/podcasts. A special shout out to our producer, Jessica Londa. Happy trails to you until we meet again. Our soundmen, Dan Casper and Frankie Martin, editor Michelle Stone, and our production manager, Amanda Griffin. Tune in next month as we wrangle some ranch hands you may not expect to find around these parts. And remember, on the Rocket Ranch, even the sky isn't the limit.